Welcome to qnawire.
All right, in this problem, we have a room, a volume 440 cubic meters at a temperature of 25 degrees Celsius with a humidity of about 65%. And we were asked to find the amount of water that can be evaporated from an open pan. Now, the total amount of water vapor that can be in the air can be found from the saturated vapor pressure, which is given in table 18-2. Saturated water pressure. And once we have this pressure, we can use the ideal gas law to find number of moles and ultimately the mass. So it's really this table that's important. So consulting the table, there is an entry for 25 degrees Celsius, so we don't have to do an interpolation or of any kind, which is kind of nice. We've had to do that in some other problems in this chapter. So we find that the saturated vapor pressure from the table is 3.17 times 10 to the 3 Pascal. All right, we'll use that. Using the ideal gas law, we know temperature, we know the volume of the room, and now we have pressure. So this becomes relatively simple. We just need to find the number of moles, which is just PV over RT. And we use our pressure. We can use the volume of the room, which we know. I'm just leaving the units off, but I think it should be clear what units we're using. 8.314. I'll put the units on. This is the gas constant, and it has units of joules over moles Kelvin. And from that, you know that volume has to be in meters, pascals, moles, kelvins. Those are the units we're talking about. And of course, we have to go from Celsius to Kelvin, so remember that. So we have 273 plus 20, plus 25 rather, gives us temperature in Kelvin. When we get this number, we have 563 moles of water. Okay? So the only thing left to do is once we have the total number of moles in the room, technically all of this could be evaporated in the pan if we wanted to. So to find the actual mass of the water, we just take the number of moles times the molar mass, or kilograms per mole. Now, there's one nuance here, actually, that we've got to talk about. Since the relative humidity is only 65%, the total water that can actually be evaporated is 35%, is the remaining. It's what can be evaporated in the air, so you have to be careful about that. So all we do is we multiply this number of moles, 563, by 0.35, which is the remainder. And then we multiply by this for water, 18 times 10 to the negative 3 kilograms per mole, which leaves us with about 3.5 kilograms. So just to recap, we used a table to find the saturated vapor pressure in the room, which happened to be at a value that was in the table, so we didn't have to interpolate. Once we have the pressure, we can use the ideal gas law to find the number of moles. And this is the number of moles that are in the air that's already evaporated. And because we know that it's 65% humidity, and this is the number of moles in the air, we can then determine the remainder. We can determine the remainder, which is 35% of it, of the total. And then from that, we can figure out the mass of that amount of water. And that's it.